They're all having to do with containers and management and this thing I keep saying, like a registry. But we're going to go over that and talk about what these different things mean. Now, there are a couple things that I will mention that are roadmap items for Oracle. I will point them out if we get there, but they are covered under our safe harbor, just for legal T's and C's. But today we're going to really look at the history of containers, right? And it actually goes back beyond the last 3 years or so with Docker, the company. We're going to look at some of the better use cases for containers. I get asked this question all the time. What are good applications? What are good types of things to do in containers? We're going to look at some of the basic architecture and nomenclature. So you will walk out of here, and then if I stop you in the hallway later and say, hey, what's a Docker image? You're going to be able to tell me exactly what that is. We're going to talk about why Docker's hot, and we're going to talk about some of the trends in the industry, and I'll point you to some additional resources and that type of stuff. But let's talk about the history, right? Because the history is pretty interesting. It really is all part of an evolution of a lot of different things at the same time. The evolution of the development process, everything up into today's modern DevOps. I was on a call with a big company this morning, and you would know this if they're in healthcare, and they said, we want to get beyond releasing something on a once a month basis. We want to get down to maybe even daily or even hourly types of builds, right? This whole concept of microservices, that's all part of this as well. A lot of people can misconstrue microservices and containers. Those are two separate things. You can do microservices without containers. Containers just make for a really nice way to package a microservice. And this whole phenomenon called the cloud, right? Where things are abstracted and you use compute, network, and storage just like you're plugging into to the wall to grab electricity, right? You basically rent it and use it and put it away when you don't need it. But containers have been around, believe it or not, since 1979. They've been evolved in Unix and Linux more recently, and there's probably even more on top of this as we've moved forward. The important thing is to know that this technology called containerization is not necessarily new. But what is new is the phenomenon that the startup company called Docker created the buzz, because they created a technology that was usable by mere humans. Prior to the way they packaged it up, you had to have a PhD in something to really be able to use these types of technologies. They really brought this type of movement to the masses, and that's the key thing to take away from this. So a lot of people, and we'll get into, what are all these, what is specifically containerization, but I really like to cover, because I was an application development manager. I worked for a company called Compaq Computer. I was actually in the IT group. I was a development manager and director, and my responsibility was all the sales and marketing apps that Compaq used worldwide, right? And we did some crazy stuff in some technologies called Lotus Notes, Oracle Database, and writing front-end client-server applications. This is 20 years ago. So this whole area has changed, and we're, as we're moving forward, right? So let's talk about some of the better use cases, right? And there are 5 little blocks here, and some of them interrelate. And let me walk through it. So the first is ready-to-run application stacks. And I think this is one of the coolest things because, for example, if you go out and you look at some of the Docker labs that I've written, I've got a little WordPress stack, WordPress and SQL Server, right? And if I were to say to anybody in the room, hey, go fire up WordPress and put a database behind it, and let me know how long that takes you. And, it could take you hours or days to put that up on some server somewhere and get that up and running. where I can give you this little, what I call a stack. It's a Docker compose file, and you could run that, and you literally, the containers will be up in seconds, and you will have a ready-to-use WordPress application. Did you know exactly, what it is? But you did it, right? These containers come up, they're ready to run. When you access WordPress, you log into it just like you were logging in on a server. So the ready-to-run stack is a really cool concept. So this is extended now today with things called Helm charts, which is used in a technology called Kubernetes to stand up a more complex collection of containers that interact with each other. So this whole thing is pretty cool. And you can literally do this type of stuff now in seconds or minutes, where it may have taken you days to do these types of stand up some of these apps. The other thing is new application development and microservices. How many people heard about 12-step refactoring as far as moving something into a microservice? So what containers are really good for is if you were to take an application that you already have and refactor it and rebuild it and redevelop it with containers. Now you could do the whole application or maybe just a section of it. And let me talk to you about that. It worked, and this goes hand in hand with the front-end app servers on the right-hand side. Worked with a bank. They were a regional bank. They had to compete against the big guys, Wells Fargo and Bank of America and those types of companies. And how does a regional bank or smaller local bank compete nowadays? They don't compete by getting you in their branches and giving you all this wonderful service, right? They compete by building the best mobile and browser-based applications to do your consumer banking on them, with them, right? And so they took a legacy application, their banking application, and they just containerized the front end. And containerizing the front end allowed them to increase the user experience, even though all the transactions were still being done on the back end through middleware and traditional type databases. But the front end experience was based in containers. And they were able to iterate on this and get feedback and improve it and really create a great mobile and browser experience. So those things kind of go hand in hand. Back on the left, one-time run jobs and analytics. There's a company called SAS. They make a big application for statistical analysis. And they discovered that, to take their app and run it might take a couple days to get that set up. So they're starting to put that in a container, a big app, like 9 gigs in a container. Run it, and folks can try it, run their analysis, spin it up, spin it down, take the data, and they're done. So one-time run jobs, analytics, great use case for containers. Again, front-end app servers, front-end app servers have the ability, you're deploying these behind a load balancer, so you can do these things called canary deployments and rolling deployments, or maybe, you're segmenting your traffic. 50% get the new version, 50% get the old version. You can test, A/B test between them, then roll everybody to the newest version. A lot of innovation with that type of methodology. This whole concept of cattle, not pets, right? We don't name containers, right, like servers. We don't care if a container dies. A container does work. If it goes away, another one takes its place. If we need to scale, we just scale. If we need to descale, we descale. They're built to just exist or not exist, to do their work and go away. They're ephemeral, right? By design, they do not retain data. You have to build in data retention mechanisms in which to pull the data out, right, and persist that. But by themselves, they're ephemeral. And then server density, right? Again, I'm talking to this account this morning. They were running Docker containers on bare metal, no hypervisor. They thought that was great, There's a certain company that a lot of people want to push to the side. First letter of that company is V, right? So The idea of running on compute directly without a hypervisor has a bunch of positives, including performance and server density. So the ability to bin pack and to maximize the amount of containers that you're doing that are doing work, given your compute behind it, that's key. Those are great use cases, right? What's not on there? Database. I don't necessarily think database is a great use case for containers. There are great database ways to run databases today. Sort of like what virtualization was, right? Was databases virtualized in the beginning? Not necessarily. So I think we'll continue to see the evolution of containers, but maybe using database as bringing up a dev test environment and doing some testing and having a DB running in a test container, that might be a good use case. But production, I really think you should put that on some kick-ass dedicated platform for the database, my opinion, right? But again, those things that are ephemeral, come up, do work, you don't care if they go away, those are great use cases. This is back from 2016. Seems like ancient history. I get almost embarrassed by putting something up there with a date two years ago. But the reason people are using containers hasn't changed. It's a DevOps story, right? It's a developers. It does help, in migrating to the clouds. One thing that containers are very portable, right? So I have a container. I can basically run that container on any Linux server that's running the Docker engine. Makes it very portable. I don't have to have all the dependent libraries that the application needs. Those are all built into the container. So let's talk about that architecture and some of those terms here. If I were to compare a virtual machine to a container, those things are quite different, right? A virtual machine, again, runs on top of a hypervisor. The file has a complete copy of the guest operating system. Again, whether that be Windows or Linux or whatever, it's a complete copy of the guest operating system in there. And then inside a virtual machine, you can put your application libraries and everything you might need to run an application, and you install the application. Whereas a container runs on top of basically the Docker engine. The Docker engine provides every Linux server has to have this Docker engine installed for the container to run. And the container shares the kernel of that Linux operating system. It does not have to have a full Linux OS built into the container. You just have basically what dependencies that the application needs to run in the container. Maybe whatever setup and so on and so forth. But it shares the kernel, so it's much smaller. And it's much quicker to basically boot or to come up, right? So a VM could take a couple minutes to come up and run all the things it needs to run. A container, I've seen containers come up in a second. They just are there and they're ready to run. And it's an amazing thing. So a container, basically the takeaways here are containers are very lightweight. They have only what they need to run the application. It makes it portable. I can run that basically on any Linux server that's running the Docker engine, just the same way each and every time. And that, I'll preface that with, there's a 90-some%, probability here. So there are cases where there are a little bit of dependencies on some containers, but most open source containers just run them where you want. So the architecture, right? What makes up some of this stuff? So if you're on your laptop and you want to interface with Docker, you might use the Docker CLI. So you could install Docker on your Mac very, very easily. You can install Docker in a VM. You can install it in a server. But the way that you connect with it is through a CLI, a command line interface, known as the Docker client or the Docker CLI. And it's just when if you're at a command prompt, basically, or a terminal window, and you issue a command like Docker run, right? The CLI is you just are communicating with the Docker engine directly through this CLI. A Docker file. Now, a Docker file is like a recipe, and I'll show you an example of one of these. It's a recipe of instructions on how to assemble a Docker image, right? So you got this Docker file. It's sort of the instructions. It says do this, take this base OS, layer on this app, and do this configuration. And then when you run the Docker file to create the Docker image, right? The image then is basically when you run the image, the container is the result of running that image. So the container is the running instantiation of a Docker image. Docker images either live locally on your laptop, like you could create them there, or you could create them up on a server, right? And then if you want to put them somewhere, that's where the registry comes in. So registry is a place that people can write images to, and the Docker Hub is probably the biggest registry in the world. It's got thousands and thousands of images that all the public images, you can just go pull down and run a copy of Nginx or Redis or whatever image you might want to run, but those images live in registries. So just to be clear, Docker files is the recipe. You create an image. An image is stored on your laptop. You can push that up to a registry like Docker Hub. Once it's on Docker Hub, you make it public. Everybody in the room could share it and run that container wherever you want to run it. Make sense? Okay, so the Docker engine is a daemon that runs on the Linux server, and it has all the knowledge of how to run these containers. And Docker, the company, is innovating around some of the things that you can do here, but the Docker engine is the specific things that you need to run on your server or your laptop or wherever you're doing this for the containers to run. Once it's installed, you run containers all day long. It's a beautiful thing. If you come to the lab later, one of the first things that we're going to do is I'm going to say, well, do you have Docker installed, the Docker engine, somewhere? Because the exercises that we'll do in the lab, we got to run them somewhere. So there's a little bit of a hurdle here now getting the environment set up. But we'll talk about that in the lab, and there's a few options, including using some trial, Oracle trial VMs and such like that you can do. So Docker images is based on a layered file system. When you look at an image, you can see the layers. They're actually visible, and it has the software built in that you want to run with the configuration and whatever OS stuff that it needs. And those layers are read-only. So if I run a container, if I run the image and run that container, whatever, if I log in, let's take that WordPress example, right? If I log into WordPress and I write a blog, and that blog, some of the information is saved to the MySQL database, right? And I stop those containers, that data's gone. Unless I persist it out to a local volume or some other types of storage. So, images and containers, again, are basically read-only. Here's a great, this Docker file is just a Hello World example. It's an actual Docker file from a coworker of mine by the name of Scott Baldwin. It's out on GitHub. You can go to that URL. This presentation will be available to you. It'll be up on the site. So you can go back and look at this Docker file, and you can build it. The way you build it is you do over on the right, docker build -t hello world, and you give it a tag name. We're calling this 1.0, and it'll go with the Docker engine installed. It'll build what's on the left, right, which is basically an Nginx app that when it comes up, it says hello world. Very complex, but yet I'm teasing about the complexity. But it gives you a good idea of, a basic Docker file and how that's constructed. And then I mentioned Docker Hub, the registry. I go back to the registry. I'm actually product manager for the Oracle cloud infrastructure registry that will come out a little bit later this year. But a registry is basically a place to put images. Nothing more complex than that. And images can live in repositories or repos, and those can be private or public, depending upon how you set it, right? And those allow you to share images. And, like I say, Docker Hub allows people to share images with the world. If you're working in an organization or a company, obviously you could run your own registry, right? And put things in it, run that on-prem, run it in the cloud, run it wherever you want. The most important thing to walk away with here is a registry is just simply a place to put images. There's public ones like the Docker Hub and other technologies like Quay and so on and so forth, or people spin up their own too. The Docker CLI, here's a list of, not an inclusive list, but a list of sample commands that you might want to run with the Docker CLI, including Docker build. What do we use Docker build for? To take that Docker file and to create an image. Docker run runs an image, right? All these things allow you to manipulate basically the Docker files and the images and run those as containers. And this is great at the elemental level. So using the Docker CLI to run a container, very, very easy. Everybody in this room could, if I gave you a Docker environment, it could be as easy as Docker run hello world, and something would happen, right? Something would happen. So for example, a very simple Docker command is Docker run hello world. That will do something. By default, it will pull down the hello world public image off the Docker Hub, and it will spit out some text in the terminal window and say, hey, you've just run your first container and a bunch of other stuff, and it will run, okay? Docker run can also be fairly complex, right? The bottom example is an example of an actual private registry, right? Because a registry can actually be a running container, right, that's persisted, the data is persisted, and all of that know-how of how that container is run is in this command. And it relies on things like certificates. Why? Because it's an actual private registry that you would use HTTPS or SSL to connect to. You would authenticate to it. You'd push your image to it securely over SSL. It would write that out to a volume. The volumes are down, the dash Vs are where the certs and the registry images themselves are stored on the local server volume in this case. But all that stuff, all that intelligence is built into the Docker run command. And what the funny thing is, to actually find out how to do that this command took me about 3 days. But once I did it, everybody in this room could run that command and run it very, very easily, which goes back to the portability thing. So again, what we're talking about here is at the elemental level. When I say elemental level, I'm talking about single containers. The hello world container that I'm running here, that's one container. The registry I'm running here is one container. How many people only have one thing running in their application, right? It's made up of a bunch of different things, and those things have to work together. I'll go back to the WordPress example. WordPress is on the right. It includes MySQL and a WordPress container, 2 containers. So we've moved from 1 to 2. And now our complexity level has increased a lot, right? In order to run 2 containers together, I can't use the Docker CLI, right? I can't necessarily use the Docker engine alone. I have to go out and install another application called Docker Compose. Docker Compose then gives me the ability to run a docker-compose YML file, YAML file, and to orchestrate together two containers that interact with each other. And if you ran what's on the right, it'll run. It'll spin up a WordPress instance, application instance. It'll spin up a MySQL database. You can connect to it, right, through the normal way that you connect to WordPress. You create a login. You log into it. You write your first blog. You kill the containers. What happens to that blog? Anybody? Disappears. Disappears. Unless you have some persistence in there. And you see, I wonder if my little laser's working. It's working, but it won't show up over there. So you see in there the where it says volumes and it says /var, www, HTML, that type of thing. There's a volume statement in each one of those. That's how you persist the data. So I'm telling the containers to write their data out, both from the MySQL piece. And funny enough, WordPress doesn't keep a lot of the metadata in the MySQL part. It actually writes it into the volume. But anyway, that's the secret there. So that's two containers. So we've talked about one container, two container, but what about three or more? Well, that's where it gets really interesting. So we'll come back to that thing in a sec. So why Docker is hot? Docker is hot because it really allows a lot of the evolution of modern day computing. It's great for dev test, and I say dev test of legacy apps. Go back to the concept I said where I could give you a stack. I can give you a stack that runs WebLogic, right? A whole WebLogic cluster. I can put that in containers, and I can use that to test against because I can spin up this WebLogic cluster like that, 2 minutes, but pretty much like that. Do my testing, tear it down. So testing of legacy apps, new app development, we talked about that, utilizing microservices and such. Allows you to do, this thing called CI/CD, continuous integration, continuous delivery of code, because I can iterate on that Docker file and make a new image and put that out there and test it and see how that performs versus the previous one. If it doesn't perform, I get rid of it and go on to the next one. It's a beautiful thing. It allows you to adopt open source. Yeah, Oracle's up here today talking about open source. We do a lot of things in open source. We're like a platinum member of the CNCF, the Cloud Native Computing Foundation. We are a contributor to the Kubernetes project. We've written a lot of open source. You go out on GitHub/Oracle. It's chock full of stuff that we've put out there for you to use freely. It's great. So it allows you to utilize a lot of this stuff, in our cloud, as you need, and just pay for what you use in the cloud. And then it allows you to move to microservices and basically cloud or now container native applications. This is a new word. We've moved beyond cloud native. Now we're talking about container native. So containers are a first, priority type object. And then, developers care because it gives them innovation and ability to iterate on images and code and push that freely. And IT cares because the stuff runs the same way in dev and test as it does in production. It allows you to easily move stuff out into production. And again, the guys that I talked to today, they were rolling monthly builds, right? Well, they know that adopting this type of process allows them to be a little bit more flexible and to push builds much more frequently. Okay, let's go back. And when I use the word functions here, I mean actual things like, capabilities, right? I'm not talking about, there's another type of functions that's evolved, which is part and parcel with serverless. The lab this afternoon will go into that functions. probably change that word on the slide because now it's overused. Hate overused words. You know, tag's another overused word. It has a completely different connotation in Docker as it does with other things. But at the end of the day, the basic Docker engine, Docker Compose, gives you the ability to run 1 or 2 containers. However, you want to orchestrate a whole application. And this is where the whole orchestration market has evolved, right? Again, I told you I was part of an acquired company called StackEngine back in 2015. We had a Docker management solution and gave you the ability to orchestrate many, many containers and run them together, right? That product exists today as Oracle Container Cloud Service Classic. And now it's got the Classic designation, which means it's a first generation container management product, right? We will be introducing and anticipate the introduction, and this is one of those safe harbor things, the introduction of a managed Kubernetes service a little later this year, right? Managed Kubernetes basically means that we stand up all the hard stuff. You just go use the clusters, right? And you use native Kubernetes orchestration to orchestrate the Docker containers that are running in it. Now, Docker had its own technology for this called Swarm, right? And Swarm and Kubernetes, you know, if you look at a horse race, they were running neck and neck through, what are we in, 2018 now? You know, 2016, 2017. But really, Kubernetes has pulled ahead. The majority of organizations now want to move towards using Kubernetes because it provides a uniform way in which to tell containers how to run together in a compute cluster, right? All it is a container, all it is. It's very sophisticated software. Google developed it. They put it out as true open source. It's managed by the CNCF as one of their projects. Like the Apache group, CNCF is another group. They manage Kubernetes. And it is by far the leading horse in this race as far as orchestration. Is it the easiest to use? No, it is not. It's not necessarily easy, but it works. Once you get your manifests, these things remember that Docker Compose file? It was a YAML file. So the way you run these Kubernetes orchestrations is also through YAML. And it's basically a description of how those containers should run. There's plenty of examples of those out on the internet. But again, this has now gone beyond Docker, the company. Now we're talking about Docker, the ecosystem, which now includes orchestration, which now includes Kubernetes as the lead character in this show. And this is just after, 3-4 years of doing containerization. All of this has evolved. So good stuff here. As far as what Oracle does, if you wanted to use Docker within our cloud, on the left is a DIY approach where you can go install Kubernetes. Go look it up. It's really funny. This guy by the name of Kelsey Hightower did it's out on GitHub. It's called Kubernetes the Hard Way. It tells you exactly how to set up Kubernetes. And it's a step-by-step process. You can go do that. You could use Oracle Linux, which supports Kubernetes as an orchestrator, supports Docker. Now 1706 CE version natively. You can go stand that up. You could use Docker Swarm out there. You could use Mesos out there. That's all a DIY experience. Or the middle box, sort of the Goldilocks thing, right? The middle box is the Terraform installer. So we have a OCI. OCI stands for Oracle Cloud Infrastructure Terraform installer for Kubernetes. It's out on GitHub. It's open source. You can take it. You can orchestrate a 3-master, redundant, and 3 ADs Kubernetes cluster and go use it. On that Kubernetes cluster, you can run Docker. Remember, Docker worker nodes run in Kubernetes clusters. And those are running the Docker engine, right? Comes back to the elemental factor of what's running on each of those Linux servers, whether that be bare metal or VMs. We have both of those available in our cloud. And then again, Safe Harbor applies. A little later this year, we're going to have the Oracle Cloud Infrastructure Container Engine for Kubernetes, which is the managed service, which means that Oracle will spin up those masters and the etcd clusters, in which then you just connect through the Kubernetes CLI, known as kubectl or kubectl, to your Docker cluster, and utilizing the manifests or Helm charts or whatever, launch your containers as you need, orchestrated in that cluster. Taking the hard part out of spinning up a Kubernetes cluster. Go back to what I said about Kelsey Hightower. Kubernetes the hard way. This is the easy way. It's all spun up for you, all managed, that type of thing. So that's a little bit about what Oracle is doing in this space. Again, you know, it almost seems like Kubernetes now is outshining what Docker is. So now you guys are thinking, well, I've been to this Docker 101 session, now I got to go to Kubernetes 101. That's a whole nother ball of wax, right? I've got something on that too, but more about that later. So a couple additional resources. Just for fun, I do have a Docker lab, a full, you know, let's say you know nothing, well, everything you know about Docker containers, let's say you learned in this room. And maybe you knew how to spell it before you walked in this room. And now you guys want to go try some hands-on. I've got this great lab on GitHub. It's GitHub/Oracle. I wrote it. It's called Docker 001. I didn't even approach the 101. I wanted to make sure that, you know, a lot of the information we just covered is in the first section of this. You go in, you verify your thing. This afternoon, if you're in the Docker and Functions lab, you'll be doing sections 1, or actually 2, 3, and 4 of this lab here. But it's also got, you know, takes everything we talked about in this talk. You run a Docker Compose file. You go in, you create a WordPress blog. You will destroy the containers. Your blog will disappear. You go back, you'll make it persistent, and your blog will persist. Anyway, that's good stuff. If you do want to know about more about our Gen 1 service, Container Cloud Service, Classic, it's also out there. And if you have one of those trials, I heard we're like giving away free cloud trials, you can spin that up. And then there's some great, when you log into it, there's some ready to run stacks that you can just deploy and run with that. And then actually, Oracle runs official image repositories as well. So if you want to get an image for WebLogic or you want to get an image for the database, you can either go to the Docker store, right, which is part of the Docker Hub, or we also run our own registry called the Oracle Container Registry, where you can pull down those images as well. And again, that gives you the ability to quickly spin up any of the things that we've wrapped as an image that you can spin up as a container. So I just referenced a couple of those for you guys. And we're at 11:55, which is perfect, and just wanted to maybe see if there are any questions. I may have a hard time hearing you, so speak up. Let's go with this guy right here.
So my question is, are there any GUI tools for dealing with Docker, images, configuration, settings?
Yes. Well, Oracle Container Cloud Service is GUI based, FYI. Check that out. Within Kubernetes, there is the Kubernetes dashboard, which, again, Kubernetes is an open source project. They provide a dashboard. So there are some GUI tools. There's also technologies out there that, like Rancher, for example, which is GUI based. So yes, there are some GUI based things for the construction of containers. Let's say you don't want to use Docker files to do this. We actually bought a company called Verker, W-E-R-C-K-E-R, and you can go to verker.com right now, sign up for a free account. They're container native. You would build containers with Verker and then push to wherever you want to run them. So it's a pretty nice, GUI-based thing. They also have a CLI. So all those tools are available. Good question, though. Right here, sir.
Can you run CopperEgg on a virtual machine?
Yes. Oh, absolutely. Yes, the question was, can you run CopperEgg on a virtual machine? Absolutely. CopperEgg will run on a VirtualBox VM, it'll run on a cloud VM, it'll run on a VMware VM. You get into this thing with Linux and Windows. Somebody might ask this, what about Windows, right? I've actually never seen a Windows container in the wild. Never. Only in a Petri dish. 99.9% of the market is Linux. Absolutely. Can you install Docker on Windows Server 2016? Yes. Can you install it on Windows 10 Business Edition, or it's not the Home Edition, the next one up? Yes. 16 gigs of RAM. Need to make sure the virtualization flag is in the BIOS, things like that, but it'll run. It only took me half a day to get it running on my Windows 10 machine, right? But I tried it, it works. But, at the end of the day, Linux is the technology here, right? Does that answer the question? There was a question here. Yes, sir. So the question is, what about if you're running a licensed technology in the container? Basically, the licensing doesn't change. It's probably most similar to how it would be if you were running it in a virtual machine. Licensing does not change. Licensing is the same. It's typically based on the cores underneath. And there's this stuff called hard petitioning. And I'm not necessarily the guy to get into this. But containerization does not give you hard petitioning. So it follows the same rules that virtual machines follow. Was there another question? Yes, sir. So the workshop, and you need to pre-register for this, okay? The workshop is in Santa Anita A and B at 1:45. Had to write that down. Check with some of the folks at the front desk. If not, come see me. Any other questions? Well, great. Well, you've been a great audience. Oh, I got one question. Yes, sir. Yes. Yes. Well, it boils down to Docker by default. You can use dynamic ports, so it pushes all the ports. So if you had two applications, both wanted to use port 80. Now, Docker will take a dynamic port, which is a 32,000 range port, and the first container will run 32.8. I'm making these port numbers up. 32.872, and the second container will run 32.873. Those will each be mapped to 80 inside the container, but to the outside world, you would come in on 32, 872, and 873 respectively. With regard to the volumes, you would need to write them to separate places, right? I'm sorry, I can't hear you. Yeah, it gets a little tricky with the volumes. It really does. So that's an advanced case. But the port allocation is a beautiful thing. And again, think of a bunch of Nginx containers behind an Nginx load balancer, right? Those things will run all day long. They'll bring traffic in. They'll pump the transaction out to something. It's a beautiful use case for containers. Yes. Well, exactly. You would need to persist the data in the database. That's why I'm saying, you probably want to use a real database on a real platform. If you just want to bring up Oracle database, you can do that. in a container, and you can use it to put some test data in there and do some stuff, and then it goes away. So as long as the container is running, the data is persisted. But if the container dies, so does the data, unless it's persisted. What? Yeah. Yes. Oh, yeah. Yes. Yes. Yeah. So the thing is, yes, you need to persist the data through mapping it to a volume or an object store or something. Okay? No, there's no magic here. Something, you need to write the data somewhere, for sure. Okay, guys, you've been a great audience. Thank you. Appreciate it.